I started this problem by graphing this in my calculator, being careful with parentheses, and I'm looking for any vertical asymptotes, horizontal asymptotes, as well as x and y intercepts. Okay, and to figure out these things, I think we're going to have to factor the equation. So I'm going to place that off to the side where, okay, this expression, the numerator, I think can factor into two pieces. Let's see, I have to have an x and an x, a -2 and a -8. I think it's got to be -4 and +2. The product is -8 and the sum is -2. For the denominator, I have to have an x and an x, a negative and a positive. I think it's going to be -7 and +5. The sum is -2. The product is -35. All that being said, I now know that the vertical asymptotes are at 7 as well as -5. These are the two values that make the denominator equal to 0. So I'm going to write those in. -1, 2, 3, 4, 5. There's a vertical asymptote here. Kind of looks like that on my graph. And then 1, 2, 3, 4, 5, 6, 7. And that seems about right too, that there's vertical asymptotes at those two numbers. I can see that the horizontal asymptote is equal to 1, and that's coming from the ratio of the two numbers and from the x's, which is 1/1. I'll just simply put 1, and that seems about right too. On my graph, y equals 1 is right there. The x-intercepts are the numbers that make the numerator 0, which would have to be -2 as well as +4. So I'm going to mark those. -2, +4. And then the y-intercept is what you get if you put 0 in place of the x's. It's going to be positive. It's going to be 8/35, whatever number that is. It's some value that is greater than 0. And I'm now ready to sketch my graph. Although I want to look at one other thing. Is it possible that my function might cross the horizontal asymptote? I want to solve this equation. If I do, I'm asking, does my graph ever equal 1? Like maybe over here the graph comes down, crosses, and then comes back up. Or maybe that happens over here. It actually equals 1 at some point before it comes back up. To address this, I'm going to solve this. Kind of looks like a pretty complicated equation, but it's actually a very simple one. I'm going to take this entire denominator, multiply it over here, and this changes my equation to x, what? It changes it to x squared minus 2x minus 8 is equal to x squared minus 2x minus 35. I can cancel the x squareds from both sides, but also I can cancel the -2x's. And this leaves me with -8 is equal to -35. That is a false statement. And this is great news. There are no solutions to this equation. The graph never equals 1 at all. It can never exist on this line. Said another way, when I sketch in my equation, I know it has to pass through these intercepts and approach the asymptotes. That's what I'm seeing on my screen. But over here, the graph never is equal to 1. It only continues to get closer and closer to it. And the same thing happens on this side as well. If I now want to answer this part of the problem, where is my function equal to or greater than 1, it would have to refer to this portion of the graph and this portion of the graph. Here's y is equal to 1, and this piece are always above it. So I'm going to highlight that. We're looking for this part of the graph and this part of the graph. That means my answer is as follows. From -infinity to -5, and also from 7 to +infinity, these are the two places where the graph is always greater than or equal to 1. So I entered this graph into my calculator, and it looks a little different than the first one. Like I see there's a piece over here, But this time the graph doesn't go down like this. Instead, it kind of like goes up, and there's a piece that shows up over here. So I want to try to identify these four things on the graph. But again, I'm going to start by taking my equation and factoring it. The numerator factors into two pieces, and I think the denominator does as well. For the numerator, I have to have an x and an x. I have to have a positive and a negative, and I think it's got to be 3 and 3. The product is -9, and the sum is 0, which is why there are no x's written in this expression. For the denominator, okay, it's got to be x and x. It's got to be a positive and a negative. I think it's got to be positive 6 and -1. I can now identify all of the pieces on the graph. The vertical asymptotes are located at -6 and also +1. That appears to be correct. 1, 2, 3, 4, 5, 6. Something that happens there. But also at +1, it looks like there's a vertical asymptote as well. The horizontal asymptote is 1. Again, that's coming from the ratio of the two numbers in front of the highest powered x terms, which are both 1. So I'm going to draw that in on my graph. And let's see, x-intercepts are going to be positive and -3 for x. And that appears to be right as well. There's a spot here, and it looks like there's a spot here. And for my y-intercept, it's got to be -9 over -6. That's the two numbers at the end. And that is 3/2. So you could even say 1.5. So that's actually kind of easy to find. That's like right here. So when I go in to sketch my graph, I know it has to go through these two intercepts and approach the asymptotes. I have the piece over here and over here. And actually, I can see there's a spot on my graph that goes over y is equal to 1. It's somewhere around, I don't know, here. I want to know what that number is. Let's figure it out. I'm going to take my equation, and I'm going to set it equal to 1. Or I could just simply multiply this to the other side of my equation, changing it to x squared minus 9 is equal to x squared plus 5x minus 6. Okay, so this time, the x squareds do cancel from both sides, but the x's do not. If I say add 6 to both sides, I get that -3 is equal to 5x, and if I divide both sides by 5, I actually get a solution to the equation, -3/5. I just typed that into my table and it gave me 1. So that's roughly here. -3/5. The graph actually crosses over y is equal to 1. I now have a very accurate sketch of my equation. It goes through these values and approaches the asymptotes. Over here, it goes through this point and gets really close to y equals 1. It never is equal to it. And then the same thing happens over here. We are now ready to figure out the inequality. Where is the graph equal to 1 or less than 1? I'm going to mark where that happens. Okay, that has to be all of this stuff. The graph is definitely less than 1 forever, never equals 1. But then also, we get this right up until we get to this spot, which we figured out was -3/5. Let's write down our answer. The answer to the inequality is everything from -6 to -3/5 and including -3/5, but also everything from 1, not including it, all the way to positive infinity. All right, so for this one, same idea. I want to graph this expression. Okay, I'm looking at it in my graphing calculator. Okay, for this one, I think I'm going to start by factoring the equation. So I think both the, again, numerator and denominator factor. Let's see, it's got to be x and x. It's got to be a positive and a negative. I think it's positive 2 and negative 1. And for the denominator, also positive and a negative, I think it's positive 4 and negative 2. Meaning, the vertical asymptotes are negative 4 and positive 2. Horizontal asymptote, again, is 1. The x-intercepts are negative 2 and 1. And my y-intercept is positive 1/4. Let's mark all this stuff on the graph. Okay, negative 2, positive 1, and 1/4. We could simply try to sketch this in, but I really do want to check to see if the function ever equals the horizontal asymptote, which is 1. Does that happen? Cross multiply the x squared plus 2x to the other side of my equation. These result in very simple expressions because the x squareds cancel. My equation is simply x minus 2 is equal to 2x minus 8. I think I'll subtract x from both sides, and maybe at the same time I'll also add 8. And this gives me a solution of 6 is equal to x. And I check that in my table, and what do you know? At 3, 4, 5, 6, the function is actually equal to 1. This would be a very easy thing to miss. But my graph has to approach the asymptotes and go through the intercepts. On the left side of the graph, it's always above that horizontal asymptote because it's never equal to 1. But over here, the graph has to go through this point and then start approaching from the other side. So when it comes to figuring out, well, what's the answer to the inequality, where's my function above 0, but also less than 1, that is referring to this portion of the graph and also this portion of the graph. So here's my answer. It's everything from, and not including, negative 2 to 1, but also everything from and including 6 to infinity. So I graphed this function in my calculator, and I also factored it, but something different happens here. The horizontal asymptote this time is actually going to be 0 instead of 1. I'm going to actually start there first. My horizontal asymptote is 0, and the reason is, in the numerator, there's 0x squared. We just don't write it. And 0 over 1 is equal to 0. So this time, in this example, this is my horizontal asymptote. Now in terms of the vertical asymptotes, that's not going to be very different. It's going to be negative 6 and also positive 7. My x-intercept is actually only one number. It's 0, 0. And that actually is the same thing for the y-intercept. This is a very strange example, but here is my x and y-intercept. That will only ever happen if it's on the origin. And let's see, for my vertical asymptotes, I have negative 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So when it comes to answering the question of, does this function cross the horizontal asymptote, we actually don't have to solve this equation again. We already figured it out. There's exactly one spot where this thing is equal to 0, and that's right here. So the good news is, in terms of graphing this thing, I can go right to my calculator and say, the graph goes to the asymptote, over to this x and y intercept, and then approaches this asymptote. And over here, I have this piece and this piece. To answer the inequality, when is this equation less than 0 must be referring to this and this. So the answer to this problem is everything from negative infinity to negative 6, as well as everything from 0 up to 7.